Good day, everyone. This is teacher Jonathan once again, and I would like to welcome you all in our today's virtual presentation about covalent bond or covalent bonding. Okay. In this video, we're going to describe how electrons are shared in covalent bonding. And at the end of this video, you'll be able to know how to draw diagrams to show covalent bonding in small molecules. In our previous video, we talked about ionic bonding, okay? And we already know that in ionic bonding or ionic bonds, atoms or electrons are shared, okay? When a metal atom reacts with non-metals. So this ionic bonding, okay? Metals reacts with non-metal. We also know that the outer electrons are transferred from metal atom to the non-metal atom. Ionic bonding produces ions which have the electronic structure of a noble gas. You remember the octet rule, all right? The atom's goal is to complete their valence electron, okay? And that's their happiest moment, okay? That's ionic bonding. And we already know that in ionic bonding, in order to complete the valence electron, they're going to need to gain or lose electron. Okay, always remember that electrons will be transferred. Okay, and they are in the reaction is happening in metal atom with non-metal atom. Okay, so that's ionic bonding. In covalent bonding, all right, here we go. In covalent bonding, it happens between non-metal elements. Okay, once again, remember this: covalent bonding, it's gonna be shared in non-metals only. All right, so covalent bond is shared pair of electrons. All right. So once again, let's go back to the periodic table of elements. So since we are dealing with covalent bond, we will set this all aside. Okay. This metal and the metalloids will be set aside, but we are going to deal with non-metals, all of this, except noble gases. Why? It's because they are already happy as they are, because these are all full valence shell. But we will be dealing with group 4, 5, 6, 7, 14, 15, 16, 17. You know what that means already, right? So in this video, okay, let's take for example hydrogen. All right, hydrogen. So the chemical conformation is H2. This is supposed to be subscript. It doesn't matter. Okay, so hydrogen is in group 1, right? Let's go back to the periodic table. Hydrogen is right here. Don't worry. Okay, hydrogen is also non-metal. All right, so don't be confused. Look at the color. Okay, look at the color. They are all of the same, right? Because hydrogen is also non-metal, and this hydrogen belongs to group 1. Group 1. So what do you expect in group 1? They have 1 valence electron. Okay, this one. So if we're going to draw it in energy level diagram, it's gonna look like this. All right, this is the energy level diagram. Since this is in period one, remember period one, group one, so it has uh, the first energy level. All right, and group one valence electron. So it's gonna look like this in energy level diagram. And when we say covalent bond, they are going to share one valence electron. So look at this, look at this. To make this hydrogen happy, they have to share, all right? They have to share one electron. Remember, first energy level has a maximum of 2. Octet rule, remember? The octet rule says, although this is not octet, because this is in group 1, period 1. So, meaning to say, this here will have 1 electron and a maximum of 2. So, if we're going to count, all right, so if this atom here has 1, they need to share 1. So to make them happy, they're going to share. So for this is 1, and they're gonna share another 1. So this will make 2. This will make 2 as well. All right, and how do we count? So since this is 2 atoms here, so we will count H2. So that's the energy level diagram. How about in a dot and cross diagram? Okay, in dot and cross diagram, sometimes we call this electron dot diagram. This one is in a British curriculum, so we will use dot and cross diagram in here. In this diagram, we're just going to draw the valence electron, not the energy level, but the valence electron. So hydrogen is in period 1, group 1, so we are expecting just 1 electron. Okay, 1 electron. But their goal is to have a full valence electron, so they're going to share. Okay, okay, so take a look now. So this one here has 2, that means full, and then this atom here has 2, full. All right, so they are going to share 1 each. Now, in stick diagram, it's going to look like this. Okay, since this is just 1, okay, these two here represent 1 stick. You got the idea? Later on, I will show you the double bond and the triple bond. All right. So since this one has 2 here, so it will represent 2 stick. Okay. So H and then the stick in the middle and then another H. Now we call it a stick diagram. All right. I think these two here looks easier. All right. And this one is also easy. Okay, because we are using the Bohr diagram. Remember the Bohr diagram? Okay, we draw the energy level and the valence electron. Okay, this also we use Bohr diagram. Except that we are using the valence electron. So it's easy. It's very easy. All right. So in this video, I'll be asking you to draw the energy level, dot and cross diagram, and then a stick diagram. Okay. Once again, group 1, period 1. So 1 energy level, 1 electron. Okay. First energy level, 1 electron. So it's gonna look like this. And since they are going to share, so it's gonna look like this. Okay, or in data in the dot and cross diagram, it's going to look like this. All right. Now, I would like you to pause this video and try chlorine atom, or the chemical formula is Cl2. This is a subscript, so don't worry. Cl2. Pause this video and then do this. All right, here we go. So, Let's go back to the periodic table once again. Where's the periodic table? The periodic table here, it says chlorine is in group 7, period 3. Group 7, period 3. Okay. Vertical, horizontal. Period, horizontal, group 17 or group 7. So, what that was that? What is that is telling us? Chlorine, since chlorine is in group 7, uh, they're going to have 7 valence electron. So let's take a look at the dot and cross diagram first. Okay, so we're going to draw the valence electrons first. Okay, since the chemical formula is Cl2, so we're gonna need 2 atoms here. So right here and then right here. They, in order for this chlorine to be happy, it needs 1 electron to fill up the valence shell. Okay, so what's going to happen? They're going to share. In the energy level diagram, they're going to share that 1 valence electron. So take a look at the overlapping here. So let's count if this is 8. Okay, so this is just 1 atom, remember? So let's count 1, 2, 3. This is the overlap. 4, 5, 6, 7, 8. So for this atom, it's already 8. Are they happy? Yes. How about for this atom? Take a look. We're gonna start right here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, they shared, remember? So for this atom, it's 8, maximum of 8. So they're both happy. That's why you call it Cl2. All right. If you're going to use the stick diagram, we're not going to worry about the rest. Since they shared this, so it's going to have 1 stick. Okay, this is the stick diagram. Cl, stick, and then Cl. All right. And that's pretty easy. Okay. Now, let's try another one. Let's try hydrogen chloride, or the chemical symbol is HCl. Pause this video and then you will check your answer. Okay, okay? Go ahead, pause. All right, so let's check your answer. Hydrogen chloride. Okay, let's go back to the periodic table again. Okay, so hydrogen here is in group 1. Okay, so that means it has 1 valence electron, remember? And then chlorine is in group 7. So it's gonna share, it's gonna need 1 electron. Oh, now I'm giving you the hint, all right? So what's gonna happen to the hydrogen chloride? Here we go, check your answer. Since hydrogen is in group 1, it's gonna need group 1 period 1. So the energy level here is in the first energy level. Okay, so remember, maximum of 2. And second, first energy level, maximum of 2 only. So group 1, it's gonna need 1. Okay, remember that. Chlorine is in period 3, group 7. Group 7. So that's why we have here 1, 2, 3, 4, 5, 6, 7. So they are going to share 1. Okay. So this is the energy level diagram, and you see that the XXXXX, right, belongs to the chlorine, and then the red dot belongs to the hydrogen. And so when they shared, remember, covalent bond is sharing electrons. Sharing is caring. Barney. Okay, so they're going to share. So is hydrogen happy? Yes. Remember, first energy level, maximum of 2 only. All right. But in chlorine, since this is in a period 3, right? Period 3. So maximum of 8. Period 2 and period 3, first and second and third energy level, maximum of 8, according to the octet rule. So in order for this chlorine to be happy, it needs one more. So let's count. 1, 2, 4, 6, 8. Happy? Yes. So they are both happy. In dot and cross diagram, it's gonna look like this. All right. So if we use circle this one, can I circle it? Okay. So this is hydrogen, right? This is hydrogen right here, and hydrogen is pretty much happy because his valence electron is full. Okay, why full? Because it's only in first energy level. Okay, chlorine is also happy because it achieved maximum of 8. This is in period 3, so it's gonna look like that. Okay, they are both happy. Hydrogen is happy, chlorine is happy. All right. If we are going to draw the stick diagram, it's going to look like this. Okay, hydrogen is a little bit smaller because this is just inferior first energy level. Chlorine is a bit bigger because this is in period 3. It has first, second, and third energy level. Okay, so sometimes we call it hydrochloric acid or simply called hydrogen fluoride. All right, so let's go ahead and get some more exercises. All right, so let's take a look at another example. Let's take another example. Okay. Now, I would like you to pause this video and I would like you to answer this next chemical formula. All right. This is water. Water is a covalent bond. So what's the chemical confirmation is H2O. Right? Pause this video and then let's check your answer. Here we go. So H2O. Let's go back again to the periodic table. Where's our periodic table? Hydrogen and oxygen. So we already know that hydrogen is in group 1, period 1, right? Right here. And oxygen is right here. So remember, covalent bond, all the non-metals. Okay, so group 1, period 1. Oxygen is in group 6, period 2. So you're expecting that this is a little bit bigger. Let's take a look. Okay, so water is this one. Okay, let's take a look at the dot diagram, the cross and the dot diagram. Okay, like what I said, like what we have known before, hydrogen is in group 1, period 1. So it has 1 valence electron. So why is it like this? Take a look first. All right, take a look. Let's apply the octet rule. Okay, the octet rule says in order for the atoms to satisfy their full valence shell, it has to have 8 electrons. All right, 8 electrons. But for hydrogen, this is period 1, so maximum of 2 only. All right? CO2, since it's in a first energy level. So hydrogen here is pretty much happy, right? Because it needs two only. And the other hydrogen here is happy because it satisfies the full octet. Okay, but let's take a look at the oxygen. Oxygen is in group 6, remember? Look at the red dots. The red dots are for the oxygen only. 2, 4, and then these two here, 6. But hey, take a look. Oxygen needed 2 electrons. So it has this atom here needed 2 atoms of hydrogen. Let's take a look at that. All right, and so that they're going to share. So oxygen here, we're going to share one atom of a. We're going to share one electron from hydrogen and another hydrogen here. Let's count it here. This is 8. So now that they are sharing, so this here will become 2. This is another 2, another 2, another 2, 2, 4, 6, 8. Okay, did you get that? And if we are going to look at the stick diagram, I think these two are stick diagram. Let's take a look. Okay, remember one stick shared 2 electrons. So let's count 2, 4, 6, 8. Got it? All right. So that is why this water here is called H2 because we are counting 2 atoms of hydrogen, then 1 atom of oxygen. H2O. All right. Does that make sense? Or if you're going to look at another model, it's gonna look like this. Okay, the red circle is the oxygen. These 2 white represent the hydrogen. Okay, but that's pretty easy. All right. Now let's take a look at another example. We have, for example, ammonia. All right, ammonia. Okay, so ammonia has a chemical formula NH3. NH3, nitrogen and hydrogen. Okay, nitrogen and hydrogen, remember? Nitrogen is in period 5. Let's take a look at the periodic table. First, nitrogen. Nitrogen is in period 5. Look at this. Okay, or 15. Group 15 or group 5, period 2. And then hydrogen is, of course, again, group 1. So ammonia is going to look like this. Okay, it's going to need 3 atoms of hydrogen to complete the octet rule. Okay, group 5, right? So how many electrons this nitrogen needed? Needed 3. Needed 3. So that is why you have hydrogen all over nitrogen. Let's count it. 2, 4, 6, 8. So it's gonna look like that. Okay, that's the computation of the electron. Okay, and this is the dot diagram. Okay, so it's gonna look like that. Or the stick diagram look like this. The 2 electrons represents one stick. One stick here. Okay, one stick here, one stick here. Needed 3 atoms of hydrogen. That's why you have NH3 or H3 right here. This one here doesn't share. Okay, only this. That's why it's gonna look like this. This is the model of NH3 or ammonia. All right. So thank you so much for watching once again, and I hope you have learned something in our virtual presentation today. Have a good day, everyone. Bye. Bye.